All right, what is up, everybody? All right, we are on our last unit, or our last section for Unit 7, parts of similar triangles. So let's quickly review all the stuff that we've talked about so far. So if two triangles are similar, then we know that corresponding angles are congruent, and we know corresponding side ratios are equal. So remember, a ratio is when we can put two numbers together to make a fraction, and we know that it would be equal to another fraction if we put it together right because of the corresponding parts. Okay. Now there are other parts of triangles that are proportional, not just the outside side lengths, okay? And those parts are the altitudes, the medians, and the angle bisectors. So remember, an altitude is a segment that's perpendicular to one side and it connects to the opposite vertex. A median, right, is connecting the two midpoints of a side. And then you have your angle bisector, which is obviously bisecting an angle, okay? So they obviously still need to be corresponding. They need to be in the same relative position when you compare the two figures, all right? And it's just to know that we can still make ratios if these are drawn in. Okay, and so that's kind of what today is all about. There's mainly just a lot of examples in the video today. There's not a lot of whole new notes. It's just kind of showing you how altitude, median, and angle bisector are used to make ratios and then set up our proportion. Okay. And so as I just said, we set up ratios just like we've been doing with the corresponding parts. And you'll kind of see as we go through the examples. Also, if you haven't printed off the outline, I would recommend doing that because it's going to save you a whole lot of time as far as drawing out all the examples for today. So as I look at this diagram right here, okay, this is an example of an altitude, right? So these two segments are altitudes, and we're assuming that both of these triangles, or all the examples that I'm giving you today, are similar triangles. Okay, so it's important to note that that altitude is being drawn from the side that has corresponding congruent angles in each one. Double arcs, single arcs, and so notice that that right angle is between those two sides. So the 16 and the x are both the altitudes of our specific, or our triangles in this instance. So my advice is just make the ratios how we previously done in 7.1 to 7.4 with the corresponding parts. So the 20 would correspond to the 15, and the 16 would correspond to the x. And so I did that as a left over right ratio. And remember, because these are similar, and those are both altitudes in the same relative position, that means that these two ratios are going to be equal because they're proportional. So I'm going to go ahead and cross multiply. I get 20x equals 15 times 16 is 240. 240 divided by 20 is 12. So that missing altitude length. So this is an example of altitudes. Okay. Let's take a look at another one. Okay, so in this one, all right, these are medians. So the reason I know that they're medians is they're connecting a midpoint of a side, and that midpoint is going to the opposite vertex. So this is an example of two medians. All right, I know that it's the midpoint because we have our single dashes here, here, and here. All right. And then remember, those single dashes are not showing that this is congruent to this. It's just showing, because they're obviously different size triangles. Okay. So when I make my ratio, I would do the x would correspond to the 3. Okay, because that 3 is this little length in purple over here. And then the 13.5 would correspond to the 9. And then we can just cross multiply. So 9x equals 13.5 times 3 is 40.5. Divided by 9 is 4.5. So our missing little length there is 4.5. So again, guys, these are medians. They're connecting the midpoint to the opposite vertex. All right? Notice, right, everything that, once we get it set up, it's the same that we've been doing, cross-multiplying, solving for our unknown. And then finally here we come to an angle bisector, right? So these are angle bisectors. We know that they're angle bisectors based off of the angles being cut in half, right? Same concept. I can go x, the angle bisector corresponds to the 8, the angle bisector in the other diagram, and the 15 would correspond to the 12. Go ahead and cross multiply them. 15 times 8 is 120. So that means our missing value for x is 10. Pretty straightforward, right? Okay, we've covered altitudes, medians, angle bisector. Okay. So next we have the angle bisector theorem, and this is where it kind of gets a little bit confusing. Hopefully it's not too bad. So the angle bisector of a triangle divides the opposite side proportionally to the other two sides of the triangle. I'll say that one more time, and then I'll kind of walk you through it in the diagram. So the angle bisector of a triangle divides the opposite side proportionally, so the side it's touching, to the other two sides of the triangle. So here's what I mean by that. So this is your angle bisector right here, okay? That angle bisector is dividing this side proportionally to this side and to this side, okay? So if you remember back when we were doing the parallel lines, okay, remember when I had something like this, and then we had a parallel line, and you had A, B, C, and D. You could do A over B equals C over D, or you could do A over C equals B over D. We're going to have something very similar here, but now this parallel line is getting replaced with this angle bisector. All right. So now that I know, I put in that JM is an angle bisector of angle J, way we can set this up. There's two different ways you can do it, and here's how I recommend this. You can make a ratio using these two sides and then making it equal to these two sides, or you can make your ratio of these two sides making it equal to these two sides. My advice is probably to stick on the same side of your angle bisector, so JK and KM, and then JL and ML. But just know that you can do it both ways. So like JK would correspond to JL, KM would correspond to ML. All right. It's up to you. Okay, so JK to KM. So again, that is if I'm sticking on the same side of my angle bisector, JL to ML, sticking on the same side of my angle bisector over there. Or I can cross the angle bisector and talk about corresponding, JK to JL, KM to ML. Notice, though, that I'm putting it in the same order, top, bottom, Now, it's going to depend on the diagram. It might be left, right, or however you want to kind of think of it in your head. But that's kind of the key to doing these problems, all right? It's all about setting up the ratios and the proportions correctly, okay? And again, the key thing to know is this angle bisector is dividing it into two triangles that you're going to be comparing. So let's take a look at a couple different examples. Okay, so this first one on the left-hand side, we have our angle bisector here in orange, right? And so the first way, if I'm going to make my ratios sticking to one side of my angle bisector, I would do x over 4, right? And so notice that the x is the left side, and the 4 is the left side. And then the 13 corresponds to the x, and the 6 corresponds to the 4. Okay? Now, if I did it the other way, where I was going to cross my angle bisector, that would be x over 13, 4 over 6. Notice I'm still cross-multiplying the same numerical numbers, right? So I get 6x equals 13 times 4, it's 52. 52 divided by 6 is 8.6, or 8.7. Now, the next one's a little bit tricky. That's kind of why I wanted to set it up. I'm going to first put this, don't worry about, I'm just going to put y right here, just so you can we can do our ratios. So option would be 11. So again, here's our angle bisector in orange. So it could be 11 over y equals 14 over x, or 11 over 14 equals y over x, right? So that's how our setup would be. Now, technically, we can't put a y in there because we need to have only one variable to solve. So here's how this would work. This distance right here in purple, okay? If I know the whole thing is 20, and I know that this section right here is x, then this distance is the total distance minus this distance right here, so 20 minus x. So what I can now do is I can go to my ratios, and wherever y was, I can replace it with 20 minus x. And however, whichever method that you chose to go with, whether it was making ratios where I'm sticking on the one side of the angle bisector, or it's a ratio where I'm crossing the angle bisector, okay? It's up to you how you want to do it. Either way is going to get you the right answer. So when we cross multiply, I get 11x equals 14 times 20 is going to be 280 minus 14x. So 11x equals 280 minus 14x. Add 14x to both sides. I get 25x equals 280. 280 divided by 25 is 11.2. So x equals 11.2. Okay. Hopefully that's not too confusing. Let me know if you have any questions. See ya.